Hello there, welcome to this video. My name is John. I provide tuition and support for A-level maths, A-level further maths, including 6-term examination papers and mathematics admissions tests. Very warm welcome to this video where we're going to take a look at a problem that I've selected from a 6-term examination paper, in particular the 2019 Step 2 paper, to have a look at in a bit more detail. So we're looking at question 2 from the 2019 Step 2 paper. This is quite an interesting little problem. Once you get your head around it, it's really quite kind of obvious, but that's the case with a lot of step problems, that once you've figured out what you need to do, it's kind of obvious. The solution almost writes itself. It's actually getting on the right track in the first place that's the difficult thing. So let's have a look. As you might expect with step problems, start out quite nice and easy, gently ease you into the problem, and then the difficulty ramps up. Okay, but just think very, very carefully about what you know. Okay, you know everything that you need to know. Just be prepared to use it. Easier said than done. So let's have a look. I'll leave a link in the description to this video so you can download the paper if you need to. But I will also have the question pop up at various times throughout the video so that you can see it as well. By the way, I've got a little bit of not a sore throat, but a dry throat. So if I do seem to be coughing and struggling a little bit, that's why. But still, I'm making this video anyway because I want to help you guys prepare for your exams. So the function f satisfies f of 0 equals 0 and f prime t is greater than 0 for t greater than 0. So in other words, the function goes through the origin, and for positive values of t, the function has a positive gradient. Show by means of a sketch that for x greater than 0, the integral from 0 to x of f of t dt plus the integral from 0 to f of x of f inverse, and they use f inverse y dy, is equal to x times f of x. Okay? And it says show by means of a sketch. So you don't need to do a purely algebraic demonstration of this. In fact, you're actually being instructed to not do that. Show by means of a sketch. So you have to interpret, you have to show that you understand how this information here relates to your sketch. So what might your sketch look like? So we might draw our f of t. So this is my t-axis, and this is my y-axis. So my function might look something like this. Okay, so it's got a positive gradient, it goes through the origin, and I'm going to choose just a value x here, and this is going to be f of x. If you haven't already noticed, already seen what you need to do, well, okay, keep watching, but it should be fairly obvious now. This area here is the integral from 0 to x of f of t dt. Okay, and this area here, unsurprisingly, is the integral from 0 to f of x of, well, it's the inverse function, kind of the inverse function. So f inverse of t, of y, sorry, dy. Okay, so I mean, compare this to what you normally do with integration, right? So if this is, you'd normally denote this as the integral from 0 to a, for example, 0 to a of f of x dx. But if you want to integrate up here, this is like integrating along the y-axis. So if you've got y equals f of x, what you would do is you'd make you make x the subject. So assuming that your function is invertible, which not all functions are, but let's assume it is for now. then we get x is equal to f inverse of y. So this integral here is the integral of f inverse of y dy from 0 to f of x. Okay, sorry, f of a. So this is what you probably find in a typical textbook. All you're doing is just changing a couple of the symbols around. It's exactly the same idea. As you can see, it's just exactly the same diagram. If you were in any doubt as to why this works. So from this you can see how this comes about. Okay? Nice and easy. How about the next part then? So the real function, that's important. It puts the word real in brackets, but that is going to be important in a second. And pay very close attention to the information that you're given, okay, in problems, especially on STEP. Now, when it comes to your normal A-level maths and A-level further maths, sometimes the information that you're given is often so formulaic, and so it doesn't really change too much, that you can kind of just become desensitized to it, so to the point where you're not really paying much attention to it. So like in mechanics, for example, you might always be told you've got a light inextensible string, and through this you can kind of almost ignore what the implications of that are. Sometimes you are asked in your exam about modeling assumptions and things like this, how they might affect things, but for the most part you can actually just do the problem in an entirely formulaic way without even ever really registering the fact that the string is a light inextensible string, for example. And there's similar situations with pure maths as well, where you're given certain conditions on a consistent basis, maybe, so much so that you kind of switch off from them. Well, don't. Those conditions are there for a very important reason. And if you're really wanting to develop your understanding of mathematics, you need to make sure that you're aware of those, what those conditions are and how they impact the decisions that you make at various times throughout your calculation. Okay, so the real function g is defined for all t by g of t cubed plus g of t equals t. Prove that g of 0 is equal to 0 and that g primes t is greater than 0 for all t. Okay, so when t equals 0, so we're concentrating on the origin here. Well, we're hoping to show that this passes through the origin. So in that case, g of 0 cubed plus g of 0 must be equal to 0, and therefore g of 0 times g of 0 squared plus 1 is equal to 0. So either g of 0 equals 0, or, importantly, g of 0 squared, maybe I should put an extra pair of brackets around that, plus 1 equals 0. Well, why can this not happen? Because g is a real function. It's a real valued function. G is real valued. So g of 0 squared is not equal to minus 1. Okay, so therefore g of 0 must be equal to 0. Okay, nice and easy. The next part show that the derivative g primes t is greater than 0 for all t. Okay, so let's have a look. What I'm going to do, I'm going to use implicit differentiation maybe here. So differentiate with respect to t. Each side of this with respect to t. So what am I going to get? I'm going to get 3g of t squared plus, dg by dt plus dg by dt is equal to 1. So therefore dg by dt, which of course is g primed of t, is going to be equal to 1 over 1 plus 3 g of t squared. Okay, but 3 of g of t squared is, that's always going to be greater than or equal to 0. So therefore 1 plus 3 of g of t squared is going to be greater than 0. Okay, we could say it's greater than or equal to 1, but it suffices to say that it's greater than 0. In which case, dg by dt, and that's for all t. Again, since g is a real valued function, so therefore dg by dt is greater than 0 for all t. In other words, g primes t is greater than 0 for all t. Okay, nice and easy. Next part. So this is where things started to get a little bit more difficult. This was nice and easy. As I was going through this, I didn't really have any problems with this bit. The next bit I had to think a bit more carefully. Okay, and I've got my notes here because there is quite a bit of algebra to go through. It's not terribly difficult algebra, it's just I need to keep track of things. So let's get rid of this. What's the point of this, by the way, is to show that we've got the right conditions. So right at the beginning we were told the function f satisfies f of 0 equals 0 and f prime t is greater than 0 for t greater than 0. Show by means of a sketch that this holds. G, the function g that we've just seen, satisfies all of those conditions, and therefore we're going to be able to use this, presumably. Okay, that should be one of the first things that you realize. That the reason that you've been asked to show these things, that g of 0 is equal to 0 and the derivatives of g is greater than 0 for all t, is that it points towards you being able to apply this. Okay, so let's have a look. Right, so what do we have? We have g of t cubed plus g of t is equal to t. Okay, so let's say that we've got something like y equals g of t. Then t is going to be equal to g inverse of y. Okay, but we know that t is equal to this thing here, which is equal to g of t cubed plus g of t, and therefore this is equal to y cubed plus y. Okay, so in other words, g inverse of y is equal to y cubed plus y. That's going to be important for us. So we've got an expression for g of t. We've got g of t, but we've also got g inverse of y. So what we know is that we need to evaluate the integral from 0 to 2 of g of t. Well, presumably this is going to be equal to 2 times g of 2, 2 times g of 2, minus the integral from 0 to g of 2 of f inverse y, or g inverse y, should I say. G inverse y, that's this thing here. Y cubed plus y dy. So I've got a few things to do here. Bit of integration, easy integration, no problems. What I initially failed to notice, and I just went through this and I got this in terms of g of 2, because I didn't realize initially that it was actually possible for us to figure out the value of g of 2. This is possible, by the way, and I'll show you in a second. But once I'd got I was hoping that maybe at some point, I didn't see how it was going to happen, but I was kind of hoping that some kind of magic would happen, that g of 2 would somehow cancel out towards the end. I couldn't really see it happening, but I just thought, you know what, let's just go ahead. Weird things happen sometimes. but it didn't happen. I got an expression for this in terms of g of 2, at which point I thought this just doesn't feel right. It just doesn't seem satisfactory. Okay, it seemed a bit too easy for a step problem. I thought I had to start thinking, how can I find the value of g of 2? Now, the problem that you've got is that you're not told anything really about this function g other than this, right? It satisfies this relationship. So for all intents and purposes, there's all sorts of functions that satisfy this relationship, right? For as far as we know. However, there might in reality only be one or a couple of functions that satisfy this relationship. We don't really know. Actually, we don't need to know. We don't need to know what g is, the equation of g. But we can still figure out the value of g of 2, and we do need to do that. Okay, so how are we going to do that? Well, let's have a look at this. When t equals 2, we get g of t. I'm going to call g of 2, I'm going to call this just x. Okay, why not? X. So what I get an equation. I get g of 2 cubed plus g of 2 is equal to t, which is equal to 2. In other words, x cubed plus x is equal to 2, or x cubed minus x minus 2 equals 0. It's cubic. Can I solve it? Yeah, of course I can. When x equals minus 1, then I get x cubed minus x minus 2 is equal to minus 1 cubed minus 1 minus, x equals 1. No, I'm messing up here, aren't I? X cubed plus x minus 2. Right, that's better. Right, when x equals 1, I get 1 cubed plus 1 minus 2 is equal to 1 plus 1 minus 2, which equals 0. So x equals 1 is a solution to this equation. So therefore, this factorizes, this expression, this cubic expression factorizes to x minus 1. You can use algebraic division if you want to, but it's a pain. I can't be bothered. X squared plus 2 minus x squared. So we don't have any x squared. Minus x squared plus x plus 2 equals 0. This quadratic here has no real roots. How can you check that? Check the discriminant, for example. Do this stuff, by the way, in your exam. I'm not writing it necessarily all here on the board, but I am making you aware of the kinds of things that are part of my solution. Even if I'm not explicitly writing them. The whole point of these videos really is not just to give you model solutions, but to give you the idea of the solution. And you can fill in some of the details if you want to. And really, I encourage you to do that. So there's no real roots. Remember, g is a real valued function. Again, it's that little bit of information that's coming in here. If g wasn't necessarily a real valued function, then this might have you're going to have complex roots and things like that. You don't have to worry about stuff like that. So for all intents and purposes, x minus 1 is the only solution. X equals 1. Sorry, x minus 1 is the only real factor. X equals 1 is the only real solution, and therefore g of 2 must be equal to 1. That's going to make things a lot easier up here, because that tells me that that's going to be just equal to 2 times 1 minus the integral from 0 to 1 of y cubed plus y dy, which is 2 minus y to the 4th over 4 plus y squared over 2, between 0 and 1. What do we get? A quarter plus a half, which is 2 minus 3 quarters, which is 5 quarters. Okay, the area, this integral is 5 quarters. Perfect. That's a much better expression than I was getting. So my original expression was in terms of g of 2. It was a quarter g of 2 multiplied by, in brackets, 6 minus g of 2, which works. It works, but it's not really what we needed. So all I can say is if you're doing something on step and it seems that it's been a little bit too easy, you probably missed something. Okay, don't get me wrong, sometimes they can put things in that are just surprisingly easy, but it doesn't happen very often on step. They're usually really well thought out, so that you've got to do some serious thinking. Okay, so job done with that. By the way, if there's anything that you're not clear about that I go through in these videos, please leave a comment in the comments section. It would also be really, really great if you could hit the subscribe button and hit the like button. I don't make any money from making these videos. I do want to continue making these videos to help people prepare for their STEP exams and their MAT and further maths exams and things like that. But I can only justify that, I can only do that if I've got the support for doing it. So if you do derive some benefit from these videos and you want me to keep making them, I'm prepared to do that, but please just hit the subscribe button, hit the like button, so that I know that there are people out there that are actually wanting me to do this stuff. Also, if you wouldn't mind sharing these videos with anybody else that you think might benefit from them. And if you've also got any ideas, any comments that you'd like to make about how I might improve these videos, please leave your comments in the comments section. Constructive criticism, please. If you're just going to say, oh, your videos are crap or something like that, okay, say that, but say why they're crap at least. So I can do something about it, potentially. Right, so on with the show. So let's get rid of that. So then we're on to the final part. Again, the real function h is defined for all t by h of t cubed plus h of t is equal to t plus 2. So it's a very similar problem, I guess, to what we had. When we had g of t cubed plus g of t is equal to t, but here we've got h of t cubed plus h of t is equal to t plus 2. So what this suggests potentially is that we're not just going to be able to use this straight off. We're going to have to be a little bit more careful, maybe. Okay, so what did we check with g? We checked that g of 0 is equal to 0, and we found that the derivative of g is greater than 0 for all t. Well, let's at least start by doing the same sort of thing. That's what I did with this. Sometimes you've just got to follow your nose. You've just got to do what you think you need to do. Either it works or it doesn't. Okay, if this didn't work, I would have to think of something else to do. But let's see what happens. So if we've got h of 0 cubed plus h of 0 is equal to 0 plus 2, which obviously equals 2. So here we're setting t equal to 0. Then we get, I'm going to write h cubed. I can't be bothered writing h of 0 all the time. So h cubed plus h minus 2 is going to be equal to 0. So what does that mean? We've kind of already solved this, haven't we? In a way, in the previous part. So if h equals 1, what do we get? We get h minus 1, h squared plus 2 plus h equals 0. So again, h is a real valued function, so there's no real roots here. Check the discriminant, so h equals 1 is the only solution. So that means that h of 0 is equal to 1. Okay, so notice how similar that is to what we did with g, but it was g of 2 that we were working with. Oh, by the way, what we're trying to evaluate here, maybe I should write that up. We're trying to evaluate this integral, 0 to 8 of h of t dt. Okay, so we're almost recycling one of the calculations that we've already done for g, but just in a slightly different context here. So what we can see here is that h of 0 is equal to 1. So it doesn't satisfy the conditions necessarily of what we had in this part here. That doesn't prevent us from using this kind of idea. It's just we're going to have to adapt it in a particular way. Okay. Let's have a look at the derivative of this. Well, actually, it's kind of similar to what we had before. In fact, so much so that we get h primes t is equal to 1 over 3 h of t squared plus 1. It's basically the same calculation. You get 3h of t squared dh by dt plus dh by dt equals 1. And you rearrange and you get this. Just like when you do implicit differentiation, for example. Okay. So I can see that that's, again, exactly the same argument as for g. That's going to be greater than 0 for all t, since h is a real function, so on and so forth. Okay, so we're not quite in the right sort of sets of circumstances, but, you know, let's have a look. What might the graph of this look like? So t, h of t. So it goes through 1, and it's got a positive gradient. So let's choose a value x here. What's this area going to be? It's going to be the integral from 0 to x of h of t dt. And, okay, what about this area here then? With this area, we can adapt this formula, right? So this is h of x. So it's not the integral from 0 to h of x. It's the integral from 1 to h of x of h inverse of y dy. Well, that's easy enough, right? We get a kind of analogous formula to this, which is that the integral from 0 to x of h of t dt plus the integral from 1 to h of x of h inverse of y dy is equal to x times h of x. So in other words, if we replace x with 8 now, which is what we're trying to figure out, 8 times h of 8, then what do I need to do? Well, again, similar to what I did in the previous, I need to just, in the previous part when I figured out the value of g of 2, I need to figure out the value of h of 8. But this is the formula that I'm going to be relying on, which is analogous to this. It's not exactly the same. Now, this is entirely typical of STEP, where you're kind of guided through something, a particular problem. You know, you might be given a certain amount of guidance, but there's still a lot of work for you to do. And then right at the very end, you're given another problem, which is something to do with what you've just done, but it's not just a regurgitation. There's something different about it, something that you've got to take into consideration. And you're really on your own, you know. You've got to go through effectively the whole process again yourself, but also building in these adaptations that are going to deal with this slightly different set of circumstances. So be prepared for stuff like that. So, okay, how can we figure out the value of h of 8? Well, in the same way that we did for g of 2. h of 8 cubed plus h of 8 is going to be equal to, so this is when t is equal to 8, by the way, it's going to be equal to 8 plus 2, which is 10. So h of 8, in fact, I'll set that equal to x because I can't be bothered writing h of 8 out all the time. So x cubed plus x minus 10 equals 0. So what do you, x equals 2. So if x equals 2, what do we get? We get 2 cubed, 8 plus 2 minus 10 equals 0. So x minus 2 is a factor theorem, right? So x squared plus 5 minus 2x squared plus 2x equals 0. So this, again, check the discriminant. It's got no real roots. So therefore, since h is a real valued function, cannot satisfy this equation. So x equals 2, and therefore h of 8 equals 2. Okay, so let's change that up in here. So I get the integral from 0 to 8 of h of t dt plus the integral from 1 to 2 of h inverse of y dy is equal to 8 times h of 8, which is 2, which is 16, obviously. So we're practically there now. All we've got to do is figure out the expression for h inverse of y. Let's have a look at that. And once we've done that, we're sorted. So let's say we've got y equals h of t. Assuming that our function is invertible and all that business, then we get h inverse of y, but t is also equal to h of t cubed plus h of t minus 2. Don't forget the minus 2, which is y cubed plus y minus 2. Okay, so in other words, h inverse of y is equal to y cubed plus y minus 2. Right, we've got everything that we need now. Let's go. Let's do this. So the integral from 0 to 8 of h of t dt is equal to 16 minus the integral from 1 to 2 of y cubed plus y minus 2 dy, which is 16 minus y to the 4th over 4 plus y squared over 2 minus 2y between 1 and 2. 16 minus, I think you get the idea now, it's going to be 16 over 4, that's 4, plus 2 squared over 2, that's 2, minus 2 times 2 is 4, minus a quarter plus a half minus 2. 16 minus, what do we get, 4, so that's 2, minus 3 quarters plus 2. 16 minus 4 minus 3 quarters, that's going to be 16 minus 3 quarters, 13 quarters. So 4 times 16 is 64. 64 minus 13 is 51. 51 quarters. Okay. So this integral is equal to 51 quarters. And that's it. We're done. I think there would be another way of going about this. So thinking back to the diagram, if you think about h, kind of translating it, this might have been a better way of going about it. I don't know. Give me your thoughts on this. Would it have been better for me to have thought about h as kind of a translate, or to have defined a new function, let's say p of t is equal to h of t minus 1, for example. Okay, because then p of t will go through the origin, its gradient will be greater than 0 for all values of t. I would have been able to use this on p of t, but what I would have had a bit of a rectangle. So think about it. This was no, that wasn't the diagram that I drew. This is the diagram that I drew for h of t. So give me your thoughts on this. So p of t would effectively, this would become the new horizontal axis. So this theorem, or this equation, would have sufficed for p of t on here, and then I'd just add on the area of this rectangle to my answer. Okay, could be another possibility. Give me your thoughts on that. It's just another way of going about things. I didn't do that, but that was something that I considered you might have been able to do as a possibility. Some of you may have considered this, and you might have been screaming at your computer screen saying, why aren't you doing this? Why aren't you doing this? I didn't do this because that's not what I thought of first off. Sometimes, when you're solving problems, yeah, there are always better ways of doing things, but sometimes you've got an idea and you just need to get going. Especially if it's an exam, you just got to get going. There might be a better way of doing it, and if you really are that good that you always see the best way of solving a problem, then congratulations. But unfortunately, I'm not one of those people. sometimes I choose to do something in a way that's less than ideal, and then once I've got through my solution, I realize, oh, I could have done it in that way instead. And that to me is how problem solving works. Okay, so that brings us to the end of this problem. If there is anything that you're not sure about, anything that you would like me to further comment on, please leave a comment in the comments section. If you've got any ideas about anything that you would like me to cover in my videos, please let me know. Like I say, I would like to continue making these videos to help people prepare for their exams. If there's anything that you think of that other YouTubers are not doing, that you maybe think that I could fill a gap somewhere, maybe there's because there's plenty of videos out there that cover all the basic stuff of A-level maths, for example. Is there anything that is being missed? Okay, let me know, because hopefully I could make some videos and I could really fill a gap there. Let me know in the comments section. Okay, but that brings us to the end of this video. So without further ado, I'll just say thank you for watching this video right to the end, and I will look forward to seeing you in the next video. Thanks a lot.